All right, like I said, we're going to build the topology on the light board. So we're going to bring CSR3 into the fold. We're going to create this interface configuration for OSPF. And then what we're going to do is we're going to observe the actual behavior. So with that being said, simple enough. We'll start over on R3. And what I'll do is I'll drag the console over such that we can see all of the devices. Now you'll see here we are going to play with DMVPN when the time comes. But right now, what I want to do is I want to do what I said I was going to do. So enable, config terminal, router, OSPF1 as my process ID. Router ID will be 0003. And then what I'm going to do is I'm going to say network, and I'm going to match my interfaces exactly. So I want to advertise the link between R2 and 3. That's going to be 10.1.23.3, match exactly. Run it in area 2, as I described. And I'm going to use network 183.133, match it exactly, and run it in area 2. All right, to verify what interfaces are running, show IP OSPF interface brief. We see the configuration here. And we see there's no neighbor out of G2 for the configuration for it. And I'm going to go ahead and get rid of the type 2 LSAs. So I'll say interface G2, and I will say IP OSPF network point to point. And that should change the configuration. And I'm going to do the exact same thing on R2. So I'm going to say config T interface G2. Sorry. Interface G2, IP OSPF network point to point. And router OSPF1 network 10.1.23.2, match it exactly. And I want to run it into area 2. Now let's make sure I did everything right. So every device that I configured, or every interface that I configured on R3 is in area 2. And every interface that I configured on R2 facing area 3, if I come over here, I'm sorry, area 2, show IP OSPF interface brief. I'm going to have one interface in area 1, two interfaces, the loopback and G2, and I'm going to have one interface G2 in area 2. And I said we would create a loopback, so I'm going to say interface loopback 1, IP address 183.122.22.255.255.255.255. And then I will say router OSPF1 network 183.122.22, match it exactly, and run it specifically in area 2. Now from R2's perspective, I should have some neighbors. Show IP OSPF neighbors. And sure enough, I have a neighbor with R1 and with R3. Now let's look at what that did. So from the perspective of this area 3, let me grab my pink marker here. We are now creating type 1 LSAs. In fact, every device in area 2 is going to create one, which means I'm going to have a 0.0.0.3, the advertising router for R3, and there's also going to be a 0.0.0.2 for R2, because R2 is actually in 2 areas. So it's going to create type 1 LSAs for area 2 and flood those into area 2. It's going to create type 2 LSAs, I'm sorry, type 1 LSAs for area 1 and flood them into area 1. And what we're going to find here is from R2's perspective, I have everything that I need enabled to be able to build a routing information base, all because of these type 1 LSAs. Now when we look at this from the perspective of the device, I'm going to go to CSR2 and I want to talk about what is going to be the result of some show commands. So my first show command is going to be show IP route OSPF. Now what that's going to do is it's going to show me the contents of the routing information base regarding prefixes that were learned via OSPF. Now, the thing that we need to pay attention to here is that when we start looking at OSPF, think back to our theory. Remember I said OSPF has an administrative distance of 110 for both internal and external prefixes. So I'll just say slash 110, 110. Now I'm going to change over to a different color pen. So with that being said, we have to recognize from CSR2's perspective, it actually has physical interfaces as well as those two loopback interfaces. So I have LO0 and I have LO1. I have G1 going towards CSR1 and I have G2 going towards CSR3. And as a direct result of the fact that it is in between two areas, Area 1 and Area 2, so we'll just circle those so they stand out, it has everything that it needs to be able to compile a database. In fact, I should have some information being learned from Area 1 and Area 2 in my routing information base, so inside of my RIB. So what should I be learning? Well, I know, based on my configuration, if I got everything set up properly, I should have prefixes in my routing table for 183.1.3.3 as a /32-bit prefix. I should have an entry for 183.1.2.2 as a 32-bit prefix. That's coming from this side. I also know that since they were advertised using a Type 1 LSA, they will actually appear in my routing table as what we call O routes. O routes are listed as intra area prefixes. So in other words, I learned them from or as being reachable in a given area. And remember, CSR2 has a foot in two worlds. I have a foot in Area 1 and I have a foot in Area 2. And that's going to be allowing me to place these prefixes as O routes. But keep in mind, there's two other networks, 10.1.12.0/24 and 10.1.23.0/24. The physical interfaces connecting these devices, as well as the fact that I have two loopbacks, 183.1.2.2 and 183.1.22.22. These were all /32-bit prefixes. However, these are what we refer to from the perspective of R2's point of view. We call these directly connected interfaces. Now, a directly connected interface is going to have a far better administrative distance. Therefore, it will actually be placed inside of the RIB, but it will not be placed inside the RIB as OSPF prefixes. So from the perspective of OSPF, these prefixes will not appear in the OSPF table. They will show up as connected interfaces. So what I want to do right now is I want to dive back into the equipment and take a look at that exact process. So like I said, from R2's perspective, show IP OSPF neighbors tells me that I have these devices as neighbors, R1 and R3. Show IP OSPF interface brief tells me that I have these four interfaces participating in the routing protocol. However, these interfaces are all directly connected. So what's going to end up happening is they're going to show up in a routing table called connected. Show IP route connected, and there they are. All of the interfaces that I have described. Ethernet, Gigabit Ethernet 1, Gigabit Ethernet 2, Gigabit Ethernet 3, and my corresponding loopback interfaces. That's interesting. No, it's directly connected, but it's not running a protocol. However, if I say show IP OSPF database, let's take a look at what we've got that's being advertised to us. Now, you'll notice on R2's perspective, I have two sets of router link state LSAs. One for Area 1, one for Area 2. Now, with that being demonstrated, it's going to be these Type 1 LSAs that I'm going to be learning and placing in my routing table. If I type show IP route OSPF and hit enter, I see that I have the 2 loopbacks in question, and I see the link to 14. I forgot about that. In fact, what I'm going to do is to clean house over here. What I'm going to do is I'm going to say do show run. Actually, I'll just say show run. I'm on CSR1. I'm going to remove that from the routing process. So I'm going to say show run pipe include Ospf, and I don't want to include, I want to say section Ospf. And we see here, there's why it's being advertised, because of this very, very general configuration. So here's what I'm going to do. Config T router Ospf1. I'm going to remove this command. I'm going to say no, paste that in there. And then what I'm going to do is I'm going to say network 10.1.12.1.0.0.0.255.25, area 1. And now that should conform to my light board. So looking at this from the perspective of R2's point of view now, I should only have the 2 loopbacks like I had suggested. And they are O routes. Now O routes tell me that they were learned from type 1 LSAs. And I should be able to, from CSR2's perspective, ping 183.1.1.1, and I'll be able to ping 183.1.3.3. However, the converse is not true. I cannot go to R1 and ping anything on the other side of CSR2. So let's say ping 10.1.12.2. Yes, I got reachability to it because that's the link connecting me to R2. Can I ping its loopback? So can I ping 183.1.2.2? I can. Can I ping 183.22.22? You notice I can't. Now what I want to do is I want to look at this on the light board, because when we look at it, I can ping from here to here, G1. I can ping from here to here, the loopback 0 interface at 183.122 that's being advertised into Ospf area 1, but I cannot ping 183.122.22 because I don't know about it. Now how do I know that I do not know about it? Well, if I type show IP route for 183.122.22, we see that it's not in my routing table. If I type show IP route again, Ospf, and look at it, we see, in fact, that the only thing that I'm learning is the loopback interface that's in my area. And that's because these are all being learned as O routes. So if I look at the routing table over here on R1, I look at that routing table, the only thing that's being advertised to me right now are type 1 LSAs that are being generated in my area. So that's going to be a prefix for this and a prefix for this. This segment is directly connected, has a much, much better administrative distance than 110. And what we're going to find is actually it's got the lowest administrative distance possible. And what we're going to find here is that the only thing that I'm actually going to learn is an O route for 183.1.2.2/32, because that's the only interface that's in my area. So because of this division between Area 2 and Area 1, I don't have any way of being able to get information out of each area. Therefore, a device or resource in R1 cannot ping anything in Area 2. Let's go ahead and drive that point home. And then what we're going to do is we're going to talk about how we would actually fix this problem. So 183.122, I have reachability. 183.22.22, I do not. If I take a look at the physical segment connecting CSR2 and CSR3, ping 10.1.23.2, I'll ping the CSR2 side of it. We see I have 0 reachability. I'm going to go ahead and just shift 666 here and break that. And what I'll do is I'm going to ping the loopback on R3, 183.133. And what we see is nothing is happening. Now, we want things to happen. I mean, at the end of the day, that's the primary goal here. The objective is to make certain that everything over there corresponds to what's happening here. And we should know, from a theoretical perspective, what's happening here. Because I said if I have 2 areas, I must have an area 0, one area 0. And that area 0 must be contiguous which means it must be the same area 0 on every device that exists between areas. A lot of people look at CSR2 and says CSR2 is an ABR, an area border router. Because the definition of an area border router, a lot of people think that it is going to be a device that has an interface in more than one area. Pursuant to Cisco's definition, that's partially true. In order for me to have an ABR, an area border router, I must have interfaces in more than one area, and one of those interfaces must be, or one of those areas must be area 0. Either a physical connection to area 0 or a logical connection to area 0. So what we want to do is we want to make certain that we understand the nature of this, and it's going to involve the introduction of a new LSA, a type 3 LSA. Now I promise we're going to roll back to type 2 LSAs, DRs and BDRs, but what I want to do is I want to cover everything that's going to allow me to be able to generate prefixes. Because if we look at CSR3 or at CSR1, any prefixes that I learned from another area is not an intra-area route. It's going to be a new type of route called an inter-area route. So when we look at what's happening here, an intra-area route is an area or a route inside my area. These prefixes are out of my area. So if I need to learn about them, I'm going to actually denote them in my database as what we call OIA prefixes. Now that means I'm going to have to remove some of this configuration here, because when I do learn these prefixes on CSR1, we'll find I'm going to learn about the loopback on CSR3. I'm going to learn about the physical connection between CSR2 and CSR3, and I'm going to learn about the loopback 1 interface on CSR2, and every one of these prefixes are going to be listed in my routing information base as OIA prefixes. And in order to be able to do that, I'm going to have to understand a new type of LSA, and that type of LSA is going to be the type 3 LSA, otherwise known as a summary LSA. Now, the rule about type 3 LSAs is, unlike type 1s and type 2s, type 3 LSAs are allowed to go through every area by default. So what we want to do is we're going to actually go through this process where we actually build an ABR in the next video. I'll see you guys there.